Hello students, today we are going to discuss very important topic, that is buffer solution. You have observed that whenever you take more amount of sour foods or you eat more chili, or if you take excess food like this, but it will be digested, and if you take more sour food, then it will be also digested. You will not feel any discomfort, because the blood is very important that is natural, that we can say natural solution, that is called natural buffer, which manage the change in pH level of the biological process, or in the body. Blood mainly control the pH level. If you take more sour food, then it will also control. So blood is one type of a natural buffer which keep the constant pH level in the blood, because your blood contains carbonate ion, and this carbonate ion mainly control the pH level. Anyway, we will discuss this thing. So which type of solution is called buffer solution? And this buffer solution is used in medical science, industrial chemistry, and in fertilizer industries, leather industry, paint industry, so many fields, in qualitative analysis, in electroplating. It has so many applications. We can say it is used in all fields, in all types of fields it has application. So which type of solution is buffer solution? Buffer solution is the solution mainly it contains, it helps to resist the change in pH level of the solution. It helps to resist the pH level of the solution, means it control or it maintain the constant pH level. That is called buffer solution. If this solution will not be present, if it will not be taken, then pH level will be changed, maybe increase or maybe decrease. So this is a very important solution, that is buffer solution, which control the pH level of the solution. And buffer solution, there are mainly two types. Now buffer generally item preparation. If you discuss the preparation of buffer, it is mainly prepared weak base or weak acid or base and salt. This buffer solution is mainly composed of, or is made up of, or is consists of weak acid and or base. Weak acid or base and its salt. Weak acid and its salt, and weak base and its salt. There are two types of buffer. One is acidic buffer, then second one is basic buffer. Acidic buffer, let us example is acetic acid, which is weak acid, and its salt is let it be sodium acetate. This is called acidic buffer. And basic buffer, let it be weak base is ammonium hydroxide and your salt is ammonium chloride. Always this thing will be taken, weak acid and its salt, weak base and its salt. That is called acidic buffer and basic buffer. Then we will discuss now buffer action, how it works. buffer action. Buffer action means how it maintain the constant pH without changing the pH level. But when we add acid or base, then pH level will be changed. But it helps to maintain the pH level of the solution. If you add acid or base, the pH level will not be affected. How it comes? Let us take the acidic buffer. Acidic buffer. If you take acidic buffer, for example, you take acetic acid. Acetic acid is a weak acid maintain equilibrium with these dissociated ions. Already you know, acid maintain its equilibrium with its all dissociated ions and undissociated acid. Let me salt is sodium acetate. As it is a highly soluble, highly dissociated form, so it produces always ions. Okay, Na plus and CH. Then how maintain? Suppose you let it be addition of H plus. If when you add acid to the solution, if you take the buffer solution, you add acid. Then when H plus will be added, this H plus will be added means already H plus present in which side? In product side. When H plus will be added, then the extra H plus which is added will combine with acetate ion. H plus ion, added H plus ion and the solution containing acetate ion combine to form acetic, undissociated acetic acid. That means equilibrium will be shifted towards backward direction if you add acid to the solution. That acid H plus is added, that H plus combined with acetate ion producing undissociated acetic acid. That acetate ion is decreased, is balanced by the dissociation of acetate ion. Okay, so this is about what? The change of pH level which is not affected by addition of H plus, because the added H plus combined with acetate ion forming undissociated acid. So no H plus ion will be increased, will not be changed in the solution. That's why we maintain constant pH level. Then similarly, by addition of OH minus, that means base. When base will be added, what happens? If OH minus is added, then the solution containing, when OH minus will be added, OH minus when added, then solution containing H plus ion forming water molecule, forming undissociated water molecule. So H plus ion is decreased from the solution. When you add OH minus, then it reacts with H plus ion forming water molecule. So we can say H plus ion is decreased. The decreased H plus ion will be balanced by that equilibrium shifting towards forward direction. So acetic acid dissociate forming H plus ion. That H plus ion is decreased by OH minus will be balanced by the dissociation of acetic acid. Because acetic acid, some undissociated particle already present in the solution and it maintains equilibrium with its ions. If H plus is decreased, then acetic acid will dissociate forming H plus ion. If H plus is increased, then acetic acid then acetate ion combined with H plus ion forming acetic acid. So this is the we know that Lee-Chatterjee principle. Equilibrium can be shifted towards forward direction, can be shifted to backward direction. It depends upon change in concentration. Here, when OH minus is added, pH will be increased, but that OH minus added will combine with H plus ion in the solution forming undissociated acetic acid. So what happens when the H plus ion is decreased from the solution, then the undissociated acetic acid dissociates forming again H plus ion. So the H plus ion will be remain same for the solution. That's why it maintain constant pH. So by addition of H plus ion, by addition of OH minus ion, there will be no change in pH level of the solution. This is about acidic buffer. Let us take the basic buffer. If you take basic buffer, let's take ammonium hydroxide with base. It will maintain equilibrium with its ion. R is weak. Then you add with this ammonium chloride. R it is a salt, highly soluble. It will produce what? Dissociated ions, ammonium ions, and Cl minus ion. Then what happens? Here, if you add, let you add addition of H plus ion, means SiO2. When H plus is added, H plus ion, added H plus ion and OH minus available in the solution and forming undissociated water molecules. So the added H plus will not affect because H plus, added H plus and already available OH minus combined with OH minus forming water, and OH minus decrease. That OH minus decrease from the solution will be balanced by the dissociation of ammonium hydroxide forming the OH minus. So the OH minus decrease will be balanced. So same way we can write also addition of OH minus. If OH minus is added, then pH will be again increased. Then when H plus added, pH will be decreased, but it is not increased or decreased due to this what action. Then when OH minus is added, so added OH minus, if OH minus is increased, when OH minus is added, OH minus combined with NH4 plus ion available in the solution forming ammonium hydroxide. So what happens? The OH minus will not be increased. It will not allow to increase the OH minus in the solution. If you add OH minus, then OH minus will combine with NH4 plus in the solution forming ammonium hydroxide. So the OH minus will not be increased. That's why pH remains same. So this is regarding the buffer action, how the acidic buffer and basic buffer maintaining the constant pH level by addition of acid and base. That is called buffer action. Then another thing is how, but important thing is buffer solution maintain constant pH. But you have to add a little solution. If you add excess acid, then there will not be, the pH level will not be control. But if you add a little bit, if you add a little amount of acid and base, there will be no change in pH. That is your called buffer action. Then what is buffer capacity? Buffer capacity, if you see, buffer capacity means that is, we can write that formula that change number of moles of acid or base, number of moles of acid or base required to bring change in what? Number of pH. Number of pH change. How much pH is per unit change? That means we can write that buffer capacity BC formula is dN by dpH. dN by dpH. What does it mean? dN means number of moles of acid or base added to the number of change of pH. How much pH is changing? That means what is the buffer capacity? Number of moles of acid or base required for change in pH level of the solution when 1 liter of solution for taking 1 liter of buffer solution. For taking 1 liter buffer solution, how many number of moles of acid or base is required to bring one pH change? To bring one pH change, how many moles of acid or base is required? That is called buffer capacity. And that for calculation of buffer capacity, we have to derive that one formula that we know. Let me one derivation I am telling, that pH of any buffer, either acidic buffer or basic buffer, pH is equal to pKa plus log into salt, the concentration, to acid concentration. pH of any solution, pH of any buffer solution, any buffer solution pH calculation is equal to pH is equal to pKa. pK means for acidic buffer, pK. pH value is equal to pKa plus log salt upon acid. Concentration of salt you can write, or you can write also that a conjugate base. That pH is equal to pKa plus log salt to acid. But for that basic buffer, pOH is equal to pKb plus log into salt to base. This is called your basic buffer, and this is called formalized for acidic buffer. For acidic buffer, pH is equal to pKa plus log salt upon acid, and for basic buffer, pOH is equal to pKb plus log salt per basic. But we know that formula, that pH plus pOH is equal to 14. This formula already we know. pH plus pOH is equal to 14. This formula you have to remember. So now we will discuss some numericals related to buffer solution. We will discuss some numericals. You finish this one. So what is buffer solution? Buffer solution is solution which maintain constant pH level even addition of acid and base. And what is buffer? How buffer is prepared? Buffer is prepared by addition of weak acid and salt, or weak base and salt. Buffer solution two types, acidic buffer and also basic buffer. These are the examples of acidic buffer and basic buffer. Then buffer action, already we have discussed how H plus or OH minus when added to the solution, either acidic buffer or basic buffer, how the pH level remaining same. There will be no change of, that means H plus will not be increased or OH minus will not be increased. It is maintaining constant pH level. Then what is buffer capacity? If what a more amount of acid and base, then pH level will be affected. Then how much number of moles of acid or base added to the 1 liter of buffer solution to bring change of 1 unit of pH. To bring 1 unit of pH, how much number of moles of acid or base is added. That's why buffer capacity is equal to D into dpH. Change in, that is how many number of moles of acid or base added to the change in pH. Then the formula pH calculation, pH is equal to pK plus log salt to acid. Salt means conjugate base after loss of H plus from the acid. So here pH is equal to pK with log and salt to base. Salt means here when base loses OH minus, that conjugate acid is produced, that is salt to base. This formula we have to remember, because acid and basic buffer both contain salt. That's why this formula is used for acidic buffer and basic buffer. Now we discuss some numericals. Okay? Let us erase this one. Question is like this. Calculate the pH of the buffer containing 0.1 m acetic acid and 0.15 m sodium acetate. And we will calculate change in pH to 1 liter of buffer by adding 1 ml of 1 m NaOH and by adding 1 ml of 1 m HCl. When HCl is added, when NaOH is added, what will be the change in pH? How much pH will be changed? We will calculate. First, let us calculate what is the pH of the buffer. As it is a acidic buffer, the formula we have pH is equal to pKa plus log what? Salt concentration to acid concentration. This is the formula. Here is a logarithm equation, just we put the data. But pK value, pK is equal to minus log Ka plus log here salt concentration minus log acid concentration. Just I have just that splitted the equation like this. Pk is equal to minus log K, log A by B is equal to log A minus log B, log A minus log B, like this. You put this, then pK, that is minus log, what is the K value? Here K of the solution is given, the K value of the solution is like this, here not written. K of the solution is 1.75 into power minus 1.75 into 10 to the power minus 5. So it is given. So minus log 1.75 into 10 to the power minus 5, then plus log your salt concentration, how much? As per the question, salt concentration 0.15 concentration, then minus log acid concentration is 0.1 m, this concentration. If you solve it using logarithmic table, you have used logarithm table 0.15, calculate. This can be also scattered, that is log 1.75, then minus plus 5, then log 0.15, then minus log here 10 to the power minus 1 means 1. It will be 1. This result will be 1. Okay, if you calculate this, the pH value, pH will be how much? pH you calculate, it will be 4.9. 4.9. This was calculate you get, because already 5 value, then it will be 1. So like this, result is 4.9. So this is the pH value of the solution. That buffer we have taken. Carefully listen what I am telling. Here the concentration of salt given, concentration of acid given, R is acidic buffer, and the K value of acidic buffer means K value given. Then what is the pH? This is the pH. Then next part is, as the pH is 4.9, if you add 1 ml of 1 ml HCl solution, then 1 ml of 1 ml NaOH solution, then what will be the change in pH level? We will calculate. Okay. Here the question is given 1 ml of 1 m NaOH solution. 1 ml of 1 m NaOH solution is equal to how many moles? Here moles will be present. How many moles present in 1 ml of? We know 1 m present in 1 liter, that is 1 mole. 1 m means 1 mole present in 1 liter solution. If the volume is 1 ml, so the number of mole of NaOH will be 10 to the power minus 3, because 1 liter 1 ml means it is 10 to the minus 3 mole. This much of mole is present in the NaOH, having 1 m NaOH and 1 ml. Volume is 1 ml and concentration is 1 m, so number of moles of NaOH is 10 to the minus 3 moles. If NaOH is 10 to this much of NaOH, and when this much of NaOH is added, it produces salt, this acetic acid, and reacts with your NaOH, forming salt, CH3CON. So how much salt is produced, how much acid will remain, we will calculate. But acid concentration is how much? Acid concentration is 0.1. So that acid will remain, acid concentration will be how much? Already it was 0.1 minus this much 0.001 m will be left. And how much remain, you calculate how much coming. That is 0.099 m. This part of acid is remain after addition of NaOH. Then how much salt will you produce? Salt, already salt concentration earlier is how much? 0.15 plus this much will be added 0.001 m. Because 1 mole NaOH produce 1 mole sodium acetate salt, that's a 10 to the minus 3 produce this much a mole of salt, so it will be added. So result is how much, you calculate how much? 0.151 m. So this is the salt concentration, this is the acid concentration after addition of 1 ml of 1 ml. Then acid concentration, salt concentration, then what is the pH value? pH is equal to that pKa plus log your salt to acid. This formula we use. If you put this data, then pK value already calculate this much, previous pK into minus log this much. If you this value you put a previous value, then log salt concentration will be how much? Salt concentration will be 0. So pKa plus log salt concentration is 0.151 concentration. Then acid concentration is 0.099. So this much, then pK value will calculate using Ka value 1.75. Your pH value will be the answer. You will calculate. Answer will be, your pH will be how much? 4.94. 4.94. Earlier it was how much? 4.9. It is 4.94. This is the value. Okay. So this is the pH value after addition of acid. Similarly, you will calculate for addition of second part. If you calculate, third part is like this, that if 1 m of HCl is added, when HCl will be added, what will happen? When acid is added, 1 ml of 1 ml of 1 m HCl is equal to 10 to the power minus 3 m HCl. Okay, so now acid concentration will be, earlier it was 0.1 m plus 0.001 m. The result is how much? 0.101 m. This is your acid concentration, and your salt concentration will be how much? When acid is added to the weak, that is buffer solution, when acid is added, then the dissociation will be decreased, because as per the common effect, when acid is added, the dissociation will be decreased. Dissociation decrease means salt concentration will be decreased. Earlier for salt concentration how much? 0.15 minus 0.001. Result is how much? How much result is coming? 0.149. 0.149. This is the concentration of acid. So you can calculate the pH. pH is equal to pKa plus log acid to salt to acid. Salt to and acid. Acid concentration. So pKa plus log your acid concentration already calculated, 0.101 upon 0.149. Sorry, just it will be reverse. Salt to acid, salt is how much? Salt to acid, salt is 0.149 upon 0.101. If you calculate, the pH value will be pH value will be how much? 4.92. That is 4.92. 4.926 is the pH value. So change in pH is calculated. Okay. So in the first case, earlier the pH was 4.9, and when base is added, pH is 4.94. How much increase? 0.04. In the first case, pH is increased. dpH is equal to first case is equal to 0.04, and the second case pH is decreased. Here, how much decrease in second case? By addition of acid, that how much result is coming? If you divide it, 0.007. That result, this much, 4.926. Here 0.49. Result will be 0.026. 0.026. This much change. Here it is decrease. Here it is decrease. Here increase. So decrease value this much, increase value this much. So we can calculate decrease this much, decrease this much, increase this much. Then we calculate buffer capacity. Like our calculation, our result is this much, but the formula buffer capacity formula is buffer capacity. You can write here buffer capacity formula, that number of moles of acid and base added, number of moles of acid and base added, how much? As per the question, number of moles of acid base added is how much? 0.001 upon how much change of pH takes place upon second factor, how much you have to deduct it. If you take this one, 0.026, this is your buffer capacity. So how much change in pH takes place, then how much of moles of acid and base added, this ratio, number of moles of acid base added to the number of value of pH change, this ratio is equal to buffer capacity. So you will calculate in this way, and if you try to practice more, then you will have better knowledge in the numericals of pH calculation, buffer capacity, and your different types of pKb calculation. Okay, thank you.